Okay. Biconditional statements. If you remember what we did on last Thursday, conditional statements.
Yes, sir.
It was like, if it rains, then the ground gets wet.
Same.
So that's an if-then. A biconditional statement, remember what bi means? Two. So if you have a conditional statement and it's true, so is this true, this conditional statement?
Yeah.
Yes. If the conditional statement is true and the converse is true, remember what to do to find the converse?
Switch it around.
Switch it around. So you'd say if the ground is wet, then it rains. That's false. That could be true, but not always. So the converse is false. In order to write a biconditional, they both have to be true. Okay? So this could not be written as a biconditional. Here's one that could be. Let's see. Okay, so here's one that's true. If x equals 2, then x plus 3 equals 5. True, right? The converse of that is if x plus 3 equals 5, then x equals 2. That's true. So, if both the statements are true, you can write it as a biconditional. That just means it doesn't matter what order you put it in. So a biconditional uses if and only if, which there's an abbreviation for that. You just put IFF. If you ever see IFF, that means if and only if. So it doesn't matter which one I put, what order I put, because it's true both ways. So you would say x equals 2 if and only if x plus 3 equals 5. So that's how you write a biconditional statement. You put the if and only if in between the two things. And like I said, it doesn't matter which one you put first. You could have said x plus 3 equals 5 if and only if x equals 2. It doesn't matter which way you put them because it's true both ways.
Why do we have to know this stuff?
This has to do with when we get into proofs, which everybody hates. You need to know how to read these statements and write these statements. So proofs are a little ways away though, thank goodness. All right, perpendicular, just a refresher for you. Everyone remember, or does anyone remember what perpendicular?
Yes, sir.
What does it do?
Guys,
What's that mean?
I remember if you told me.
90 degrees. Form a 90. Okay? So perpendicular also has an abbreviation. Instead of writing a word all the time, you can just put the upside down T to show perpendicular. If a line is perpendicular to a plane, like if this is the plane, the line would come right at it at a 90. It wouldn't come angled to it. Can you picture that?
Plane perpendicular.
So if this is the plane, the line would go right at it as a 90. It wouldn't come in at an angle. So, a lot of these are just true and false. You'll have a statement. So, we're just going to say whether they're true or false. We don't have to explain them on the assignment if it says to explain. So, quiet. Angle KLJ is right there. And angle KJL, right there, are complementary. Is that true?
Yes. No. Wait.
No, because they're not the same.
Who remembers what complementary is? Hey, shh.
Oh, they
Add up to 90. So are these two complementary? Yes. 54 plus 36 adds up to 90. Line KL, which is this line, and line LJ are perpendicular?
No.
False. You can see they don't form a 90. Angle MKJ, MKJ is right there, is a right angle.
Yes.
That's true, because remember, if this is 90, they're all 90. Okay, so it's really not much harder than that. Okay, so here they wrote a biconditional statement. X equals 2 if and only if. So if we write them, you can just put IFF. 3x plus 5x equals 10x minus 2x. So when they say, is this a biconditional statement, it means it's got to be true both ways. So first of all, we've got to solve this. 3x plus 5x is,
8x.
and this is, so if I put 2 in there, is that true?
Yeah.
Yeah. Now, if I switch the order, if I put this one first and then that, so if you said 3x plus 5x equals 10x minus 2x, which is just this, if and only if x equals 2, does x have to just equal 2 in order for this to be true?
No.
What should it be? 1, 0. It can be anything. No matter what you plug in for here and here, if you put the same number in there, it's always going to be true. So it doesn't have to be just 2. It could be 2, but it could be others. So since that way is not true, then it's not a biconditional.
So what would you put X?
You just say no. It's not a biconditional. So here we've got statements that we're going to decide whether or not it can be written as a biconditional, and then if it can, then you write it as a biconditional. So here's the conditional. So then the converse would be you switch these two around. You'd say if x equals 1, then square root of x equals 1. So first of all, is this true? If the square root of x is 1, then x equals 1?
Yeah.
Yep. If x is 1, then the square root of x equals 1.
Yep.
That's true. So then the way you'd write this is you would just say square root of x equals 1 if and only if x equals 1. So it's a lot easier to write the biconditionals. You just put the two things with an IFF in the middle. Okay, this one. If two angles are vertical, then they are congruent. Is that true? If you've got two angles that are vertical angles, remember vertical angles are across from each other. Are they congruent? True. Remember, vertical angles are congruent. So this way is true. If you switch it around, if you say if two angles are congruent, and again, when you write these out, the more you can abbreviate, go right ahead. You can put angles for the word, you can put congruent instead of the word. So if two angles are congruent, then they are vertical angles. So there's the converse, I just switched it. So if two angles are congruent, does that mean that they're vertical angles?
No.
No, you could have an angle here and an angle here that are the same, but they're not vertical. So the converse is false. This one was true, this one is false. So what that means is you can't write a biconditional. Okay? So here they've written it out. Two angles are supplementary if and only if the sum of their measures is 180. So the way you'd write it as a conditional, like we did before, you'd say if two angles are supplementary, then the sum of their measures is 180.
Yeah.
You guys know how to do that by now, right? Mm-hmm. The converse is you switch it. If the sum of two angles is 180, then they are supplementary. Okay, so one more. Here's the statement. Two segments are congruent if and only if they have the same length. Is that true? Are two segments congruent if they have the same length?
No. Yes.
In order for them to be congruent, yeah, they have to have the same length. Segments, so that's true. If we do the converse, if two segments have the same length, then they're congruent. Is that true?
Yeah.
That's true. So is this statement biconditional? Yes, because it's true both ways. Okay, we already answered that. They're both true.